Hey, what's up everybody? I'd like to welcome you to another Juce tutorial. So today what we're going to do is an implementation of a finite impulse response filter using the Juce DSP module. So I'm not going to really get into the advantages of FIR over IIR. Really, IIR has a lot more of an advantage because you could do more configurations with it, and it takes a lot less computation power than an FIR, but I won't. That might be something I might do with like a DSP presentation down the line or something like that. But we're just going to do the implementation for today. So it's a little bit different than the IIR implementation, so I just thought I'd go through this with you. So first thing that we're going to do is just go through the skeleton code that I've created. So for this one, we don't have a resonance option in the FIR example, so in the FIR implementation. So I've only got one dial, which is the filter cutoff, and then I've just kind of reworked the UI a little bit just to reflect that. And then here in the plugin processor, I've just put in some skeleton code for the actual DSP module. So I went through that 2 tutorials ago, so I'm not going to go through that all again, but you can see that I've just put a little bit of code in here just for our buffer and to relay our initial settings to the DSP module. So first thing that we're going to do, I actually tried to do this using an array rather than a process duplicator, as I've done in the last couple tutorials, but it actually won't let you do it using an array. You have to use the process or duplicator if you want to apply this filter or one of the DSP effects to more than one channel. So first thing that we're going to do is we're going to do a processor duplicator. Hopefully my autocomplete will come up. Great. So once again, I'm just going to kind of copy and paste this, and we're just going to use a type of float. So this is the FIR filter implementation here. I'm just going to take you down through it here. So we just got a couple different functions, pretty much the same as the IIR filter, but the way that we handle the coefficients is in a little bit of a different place. So this is going to be of type float. So here we go. And then we go into the coefficients to do the state type. So what you'll notice here, what's a little bit different about this than the IIR filter implementation is if we scroll down here, we'll look at the public member functions, and we got get filter order, get phase, get raw coefficients, but you'll notice there's no implementation for low pass in here or anything like that. So that's because that's in a different place, and I'll show you where that is in just a moment. So we're just going to paste this in here. I'm just going to call this of type float. Make sure all of our syntax looks nice. I'm just going to call this low pass filter. Okay, so I think we're good to go there. Then what we need to do is we just need to go into our default, our initialization list, and do a default constructor where we initialize the filter itself. So if we just go up, and so we're doing this implementation here. We're just telling it which coefficients that we want to use, and I'll show you where that is in just a moment. So we just go low pass filter, which is the name of our process duplicator. And then, actually, I'm kind of incorrect here. This would be this. I'm looking in the DSP FIR. It would be in process. It would be in processor duplicator rather than here in this FIR class. So, but it's the same thing. So I'm not going to go over there and show you. I'm sure you believe me. Okay. So all of the implementations for the coefficients for FIR are actually in a different class here. So we have DSP Filter Design. So this is a separate class where you can actually design your own filters. So we're going to implement this one here, which is a design low pass window method. So we're going to use a windowing method. I'm not really going to go into what a windowing method is. You have different types of windowing methods, but we're just going to use a Hamming window for today. And then down the line, maybe we could do more of an in-depth video just on some of the windowing concepts for filters. So I'm just going to copy that for now. Just going to put this in here. Once again, this is of type float. And then we now have access to our different methods here. So we want design FIR low pass window method. Okay. And then our frequency, we're just going to start off at 20,000 hertz. Our sample rate. Now, one question you might be asking is why am I not using the last sample rate from my last sample rate variable? And the reason is because this is in the constructor, so last sample rate hasn't even been initialized yet. So this is why I'm going to just use 44100. I'm gonna tell it the order of how many. So it's not how many coefficients. I can't profess to be an expert in this area, but I've tried a few numbers. I've experimented with a lot of different numbers. 21 is a good number, so I'm just going to use 21 for the number of so our order number. Sorry about that. So, and then windowing type, we're going to go over here, and then we have our windowing function. And so we just need to implement this. So we have a bunch of different windowing functions. We could do rectangular. We have hamming. I'm just going to do a hamming window for now. So we're just going to do this, copy all that. Paste it here. This is going to be of type float once again. And then I'm going to do hamming, and that should be good. Okay, so that's fine. I'm just going to build it real quick just to make sure that I've got all my syntax correct. So going back to the filter order number, there's a lot of there are quite a few articles out there that talk about filter order number, advantages of FIR versus IIR versus state variable filter. And like I said before, it's not something that I can say that I'm too much of an expert in. I know the basics, but there's a lot of stuff online. Maybe I'll put some links below. So okay, so we've got our low pass filter here initialized. So now what we're going to do is we're just going to go down here, and then we just need to prepare it, which is going to be where we pass it on the information from our spec. So we got low pass filter dot prepare, and then we're going to do spec, and before that we're going to reset the filter just to make sure that there are no garbage values that are remaining from if we start the music and then we're filtering and then we stop the music and then we start it again. We want to make sure there are no garbage values in there. And I'm going to also update the filter. Oh, I don't have an update function yet. So we'll just go down and make one. Okay, cool. So this is all good. And then what we can do is we can just go down here. We can do low pass filter and then process. And then once again, we're doing context. Sorry about this. It's DSP context replacing. So context replacing just means that we're using one input buffer, one output buffer. And then rather than getting adventurous, and then we're just doing that on our audio buffer. Okay, so we have this audio block that we've created called blocks. So this just points to the buffer. And then basically what this says is, okay, we're going to go and we're going to do some processing on that buffer. And then I want you to put that out to the speakers, what that processing is. So now we just need to create an update function. So I'm just going to do void all this, update filter. And then I'm just going to do the same thing in the header. Just declare it here. Void update filter. And then here, we just need to update the state of our filter. So we just need to do low pass filter. So once again, if we go back to the coefficients here, and then we go into one of the attributes here. So where is it? Oh, it's in here. Sorry. So where is it? Oh, I can't find it. But it's low. Oh, it's because it's in process duplicator. Sorry about this. So I just want to show you now. So if we go into process duplicator, this is a mistake that I make a lot. So I'm looking in FIR this whole time and wondering where it is. You got to remember that this here is not an FIR filter. It's a processor duplicator. So there are a number of methods here that don't really apply just if you're using the FIR alone, but they're specific to the processor duplicator. So if I go in here, you'll see that there's a pointer to the state. Okay, so what we can do here is we can actually use this to basically change the state. So we could do processor, sorry about this, low pass filter dot state equals, and then here we're just going to basically use the coefficients to update our filter state. So here we can go like that. This needs to be a pointer. Okay, and then here we just need to put our filter cutoff. So what I can do is I can quickly create a variable, float freak equals, and then we have our audio processor state, our audio processor value tree state. Right here we have our parameter called cutoff, and we're just going to use that so that's coming from the UI from our dial, and then we're just using that to adjust the cutoff. So we have to dereference that, so it's tree get raw parameter value, and then we're just going to the name of the value, which is cutoff. And then what I can do is I can just go in here, I can just change this to freak, and now we just need to put that in our process block so that we update the filter state, and then we can put it also in our prepare to play so it knows what filter state that we're in when we get ready to play again. So, okay, great. So I think that's everything. Let's just go ahead and try that out. So here we go. So it's Juce FIR example, and then loaded this audio file player. So it should just take a second. Okay, so we can just connect up here. And then we can just load our file player here. I'm just going to put a song. Okay, so we can hear that the filter is working. And here's our filter itself. So you can see that's quite a stable filter. Feels really nice, actually. Great, so that's the FIR implementation. I hope you liked this video. If you liked it, be sure to give it a thumbs up and subscribe if you haven't already subscribed. And I will see you next time.